Hello, I'm Jenna Flores,
I'm Ritik Shrivastava. I'm Bao.
and we are the Navy Requirement Markup Language Capstone team. So this project was sponsored by NAVC and the National Security Innovation Network, NSIN. The NSIN is a network within the U.S. Department of Defense, DoD, who works with academic and venture partners to innovate new solutions for DoD member challenges. So the problem that we were presented with was to parse through old paper Navy specification and requirement documents, which were scanned into PDF files. So these documents are typically presented in narrative form, paragraphs, for example, as shown on the bottom right. So this narrative form makes it hard for even humans to visually parse through to identify necessary information, and even more so, it's nearly impossible to parse through these documents using machines in any effective time frame. So our solution to this problem is outlined in the diagram shown. This is a level 3 autonomous system which intakes a PDF file and extracts text to create a text file through the file ingestion subsystem. Then the data labeling subsystem will read in the text file and create a nested JSON file. Using the trained NER BERT model, the system will get the entities and their types identified for the content paragraph. Finally, adding the entity and its class to the sentence and adding them to the JSON file as an element will result in a final machine-readable JSON file. Shown on the screen is a list of requirements we have outlined for this project. These requirements include specified file types, file size, and other necessary design requirements.
Here's the file ingestion subsystem, and the file ingestion subsystem is responsible for converting PDF into text file, which is then used to create input data for other subsystem. The PDF document must have text text for the content and should not contain scanned images. The input will be PDF file and the output will be corresponding text file. Up here, you can see the PDF file, and down here is the text file. For data labeling subsystem, we'll utilize Azure Machine Learning Studio, and the input will be a text file from file ingestion subsystem output, and the output will be Conan format text file for machine learning subsystem. The label data distribution for value is 43.5%, the unit is 35%, and type is 21.5%. So over here is an example for the label data. Here's value, and inches is the unit, and value type is depth.
Now, coming to the machine learning part, so our requirement was to recognize the entities in a sentence. So for that, we used name entity recognition, which is a subset of natural language processing, and it is used to identify and classify the entities into a predefined classes. Now, for doing that, we used BERT model, and it was used because like it does contextual word representations because it is good at like bidirectional learning, and it also uses fine-grained token level representations, which helps it to understand the patterns in the sentence in much better way. Then transfer learning can be done, which basically helps to learn domain specific language, and also it can handle out of vocabulary words because it uses combination of masked language model and next sentence prediction. So in our case, we basically fine-tuned our BERT model based using our prepared data, which we got from Azure, to train it uh, to make it more compatible to domain-specific language. Now, for that, we did some BERT-specific data pre-processing, such as tokenization. Then special tokens and padding tokens were added into it. Then attention mask was also added, which basically helps it to identify which tokens it has to like consider the most and which are the padded tokens as like 1 and 0 index. Then segment ID is used to identify the like first sentence and second sentence, and using these different type of tokens, it basically like adds it into the vector and then like create the vector and then send it to the machine learning model for further training.
Here is a JSON schema subsystem and output integration subsystem. So for JSON schema subsystem, we will take an input of text file and will output a dictionary having the nested structure of data. And the dictionary will have the key containing the paragraph number, and the value corresponding to the dictionary key will consist of VOI content, which contain the content of requirement with the entity classified in it, and the content will contain the original content of requirement. For the output integration subsystem, the input will be PDF file and the output will be JSON file. We will use the best model from the machine learning subsystem, export it from the machine learning subsystem and integrate the file. And after that, we'll integrate the file ingestion subsystem with PDF as input and get the output text file. We'll use the output text file for the JSON subsystem to create the nested structure. And after that, we'll also use the model for inference as to scan the document for the BOI content.
So now coming to the results of the ML model, we have provided here the graph having the loss and validation and training loss, and also the accuracy matrix. So here we have used F1 score rather than using accuracy because like we were having unbalanced data, and accuracy can give a wrong idea of model performance in case of unbalanced data. So here we can see that F1 score of unit and value is pretty high, which is more than 0.8, but in case of type, it is low. That is because the number of records for type class were much lesser than unit and value. And when we increase the training data, if we increase the training data, we can improve the F1 score of type also, and that can also help us to increase the or improve the validation loss curve. And at present, we were having restricted training data because a lot of training data was classified and wasn't provided to us. But in future, it can be like extended in that way. So now coming to the integration demo. So this is a basic project structure which we have created, in which constant.py is having like different constants such as like the parameters for the model and also the paths. In this, such as like PDF folder is the path where we have provided our source files. There are two PDF files in this particular folder which will be like converted into JSON format. Final JSON is the folder in which like JSON will be created and then like kept. And text folder is the folder in which like after extracting the text from the PDF, it will be kept in this folder, and then this text file will be picked up and then like converted into JSON format. So to run this system, we run the run.py file using the Python command. So after running this, the system basically asks to enter either model or JSON. If we enter the model, it will like start the model training process, and it takes a lot of time, so we won't be demoing that over here. So we'll write JSON, which will basically give us the result after the integration step, which is like will create the JSON files for the PDF which we have provided. So when we write JSON over here, it says that JSON file has been created. So when we check the text folder, we can see that the text extracted from the PDF has been kept over here, which can be seen like this, having paragraph number and also the sentences. And then final JSON can be seen over here. So you can see that it is also catching the like nested structure of the data, and also original content has been provided. And this BOI content key is having the like the original text content with the entities class embedded inside it. So we can see that it has classified 8 as value, 10 has been classified as value, and inches is the unit. So it is basically performing the functionality which we wanted it to perform. So now coming back to the slide, so we can see that the original PDF was in this format, which was having the requirement starting after 3. So the text is extracted, such as extracted considering that, and the output covers the nested structure of the data, which was seen in the like demo also. Now BOI context is having the entities and its type embedded inside the sentence, and original content is having the like original text which was provided in the PDF file. So yeah.
So here are some challenges we run into. We're running into some time challenges with time constraint. So to scale the solution, what we've done is that we scale the solution to JSON, and after that, that will allow for future project to scale to XML file. File ingestion subsystem also have some problem, especially with the conversion module from Python, where it's converting a PDF into text. There was some randomly inserted space in between. So what we've done is that we combine the current word and the next word, and if we check that is in the dictionary, then we'll replace that word. After that, we also run into some problem with the BERT model token limit. So BERT model have token limit of 512. What we done is that we break it into multiple input for with token 512 each. And GPU also have some memory limit. So the problem with GPU is that it can't contain all 512 of the token size. So what we done is that we make a smaller token size of 550.
Finally, we would like to thank the following people for their generous contribution and help for this project. RTA Varun, our faculty mentor, Professor Wang, and our industry mentor, Kevin Murphy and TJ McElfee.
Thank you very much.